We're in. Welcome back. Let's do more. Okay, to the screen. File. No. You. That's huge. It's huge. I love it when it's, that's great. I hope it stays huge. It didn't stay huge. Onward. We're going to do these functions. Down to the bottom. Manipulation. Flippity flips and stretchy stretches and shovey shoves in all different directions. So on all these transformations, the way these problems work, and you'll see it when you guys do your own gateway, there is a drawn function, f of x, and we're going to mess with it. So like this one, that's a vertical flip over the x-axis, that thing. This guy, horizontal flip. All the things we know and love. Up 2. Right? And then there's a sneaky one in here. That's the same as 1/2 times x. Oh, do you remember what that one does to our function? What's a half times x do? If you had to do a hand motion, what would it be? Yeah, you got to double the width. So we got double wide. So 2 times the width. Nice, double wide. You guys know what a double wide is? Just offhand. It's kind of a, in our vernacular part of the world, double wide. It's 2 side-by-side mobile homes stuck together, twice the house. Things like a mansion. So 2 mobile homes together, double wide. Just saying. All right, let's do this thing. Here is the original.
Smile, Bolsha Basic, please come to the office. Smile, Bolsha Basic, please report to the office.
I think. Hopefully, if you guys know him, let him know. Go to the office. All right, we're going to go -4, -3. This is the original. Watch carefully. All right, we're going to take the original. In these translations, it's all about noticing the 4 vertices. All we're going to do is mess with the 4 vertices. So when you do transformations and one of these rigid functions like that with corners, take all the 4 corners. Everything we do, it's basically to those corners, and then we connect the dots. So when I do a vertical flip of that function up there, I'm just going to take all the original points, which I'm to see and write at the same time. Sorry. Yours is so tiny, and I apologize for that. It does get bigger when I give you a full-size gateway. But those are the original points. And I connect them. After translation, though, which we'll do in green, that vertical flip, I know it's over the x-axis, and you could try and guess. But what you do is you take, let's start from the left, this down after reflection. The up 1 point is now down 1. The up 2 point is now down 2. And the up 4 point is now down 4. That's it. You transpose each one of those over the x-axis, and there you are. So focus on the corners. Now notice the width, totally the same. Still goes from -4 to +3. It vertically switch places. Nothing other than just a flip over the x-axis. Okay, next one. We got the H flip and the up 2. So I'm going to draw in the original again like I did before. Try and do it relatively efficiently here. Got it. Got that one. Getting better at this. 4, -3, 2, 2, and that one. I'm going to zoom in on it or draw a line. There we go. Big enough to see. That's the original. The -x piece, that horizontal flip is just like our vertical flip that we just did, except instead we're going to go across the y-axis. So I'm going to start in the left again. See how this little guy here is negative, oops, I think I went too far. Didn't I? What's the original one? It's like -4, -3. Oh, I drew it in the wrong place. Here. Fix that for you. And then -4, -3. There we go. And at that point, that's 4 chunk. After going over the x-axis, we're at +4. So you see that flip over the x-axis. The one that was left 2 is now right 2. The one that is right 2 is now left 2. And the one that was right 3 is now left 3. That's just the H flip piece, and then reconnect the dots. Get that kind of Under Armour looking symbol. Okay, that's just the negative X piece. Okay, that we got flipped over there. The up 2 piece, then you take everything you've got, shift it up 2 spaces, and we work from the green one, because we're going to move that one up 2. We'll put it in this beautiful blue color, but all the points vertically get moved up 2. That left point there goes up 2, this corner goes up 2, the other corner goes up 2, another corner up 2. It's all about the corners. Take each corner, and there you go. That's the end. Do you get the idea? Just working from those corners can be nice. Pick those vertices. Enact the transformations on the vertices and redraw it. You'll be very happy you did. I only need to see the final one, but you can show me as much as you want. Just be really clear which one you want me to say, is this correct or not? And finally, our double wide. Let's just do it. Let's double this thing. Double wide. 4, -3. I keep doing the wrong point. Let's get this just right. There we go. 4, -3. Got it. 2, 2. That one, my original. Like that. Double wide it. And to double wide means take all of the X values. This is super cool. All the X values, like if it was, now it's double width. So -4 to the left, this very first point here, that gets moved out to -8 to the left. This 2 to the left now is 4 to the left. 2 to the right now is 4 to the right. And 3 to the right is now 6 to the right. Anything through the origin, or through the y equals, or x equals, I can't talk, through the y-axis, if it touches there, it doesn't change on the y-axis because you're pulling, stretching from the y-axis. You're pulling both ends away from the y-axis. And so you just take each corner and double whatever its horizontal magnitude is. You double it in that direction. And there you are. Height-wise, totally the same height. Still goes from +4 to -3, or -3 to +4 in its range, but we've stretched it horizontally. What do you think? Those first 3, you guys kind of see where those come from? Nice little transformation. So what I'll do is you'll get a different graph each time you take a gateway, a little bit different sketch, and you always do these same transformations, these same 5. Well, might say +3 or something like that. I think it's very similar anyway. Really similar. Okay, double the f of x, that's a vertical stretch. So we got the v stretch times 2. Remember, that's as is. So when I say times 2 vertically, I mean times 2, not reciprocal. Okay, here goes. Got that one. -4, -3. Got it. Got it. Got it. There's the original. To double it vertically, each corner, if it's 3 down, now it's 6 down. 1 up, 2 up, 2 up, 4 up, 4 up, 8 up. Stretch vertically, times 2. You take the corners and you pull them from the x-axis. You're pulling away from the x-axis, making it taller. In both directions, our width is untouched. Cruising. Okay, to do the next one, we got to have the inverse function is a rotation about y equals x. So we're going to put in a little y equals x line right there. And the function, I'm going to redraw it in its usual pink. Pink, pink, pink. Nora's reading a book right now. It's like the little, like the Pink Princess and the Super Pink Party or something. This is the book she's reading. She's really into it too. So that's a lot of pink going on. But to her, the more the word pink shows up, the more fun whatever she's reading. So there you have it. What color does it for you? What gets you excited? Any special colors? Let's see. David, what would be your color? Blue. All right. Anything blue. Something borrowed, something blue. It's like a wedding thing, isn't it? Think about that. Okay, got that f of x? You good? Now, inverse is a rotation about the y equals x line. Now, I'm not going to do it willy-nilly. I'm not going to try and guess what it kind of looks like over there. I mean, I could get in there and take a ballpark. I could say, yeah, it'd probably look like that. You know, reflected over there. I'm not looking for a guess. There's a more precise way to go at it. You can take each coordinate point and mess with it. So tell me this. Riddle me this, Batman. Negative 2, 1. After I rotated about y equals x, do you know what the coordinate point would be? What? -2. They trade places. That's it. When you rotate about y equals x, they trade places. You're so right. So it'll be 1, -2 right there. That's the key to an inverse function. You swap x and y. So whatever your coordinates are on the original, this is -4, -3 in the lower left corner here. So post-reflection, it's -3, -4. Cool, huh? If it's on the axis, our y equals x line, and you rotate, spin it around the y equals x line, it's still on the y equals x line. So it stays there. It's like a hinge. It's stuck there. And finally, our last point, 3, 4 becomes 4, 3. You can plot each of those. It's not a guess, but now you can see it. Looks like a cricket, I think. Okay. Ladies and gentlemen, we have concluded the gateway. So you guys can dedicate yourself to amazing study of that, or you can just not think about it until you take it.